Welcome everyone to this new video tutorial. We're going to see right now how to track objects using the mean shift algorithm. So let's see an example. Let's say that we have this video and I want to track this sticker listering 0. So how can we do that? We can first take a picture just of listering 0. Then we can take the histogram, and using the back projection we can find in each frame, so in the video, where the object is. After that we can find the exact area and draw it like a rectangle. But let's see this step by step how it works, so it will be easy for everyone to understand. First, let's import CV2. Let's import numpy as np. Let's load the video. Is equals to cv2.video capture, and then we put the URL mouthwash.avi, and you can download this video from the link in the description. Then let's run the video while true underscore frame equals to video.read. Next, unfortunately there is a lot of noise outside, hopefully it won't bother for this video. cv2.im show frame key is equals to cv2.wait key 1. So if the key is equal to 27, which means the S key on the keyboard, we're going to break the loop. And finally video.release and cv2.destroy all windows. Let's run the code and see if everything is correct, and it is. Actually too fast, I did a mistake. So we're using the video, so we need to pause from each frame. So let's say 60, so we're going to show a frame each 60 milliseconds, which probably it's quite slow, but we don't care about this right now. Then, as I told you before, we need to get a screen, the image of the listering stickers, and I'm going to take that from the first video frame. So we're going first to capture again a frame. Frame is equals to video.read, and let's call it first frame. So you can see cv2.im show first frame you will see that it's always this one. So from this we're going to get the listering stickers, and I have already the position, I found it before, so it's x equals to 300, y equals to 305, the width is equals to 100, and the height is equals to 115. So from this we can get the ROI. So the ROI is just a name, region of interest. So the ROI in this case is the sticker. Frame is first, as we know, to get a region from an image, we need to say first which rows. So the rows are the y-axis, so from y, so from 305 to y plus height, and then from x to x plus width, and actually not from frame but we called it first frame. So we have the ROI. Let's see if it's correct. ROI is equals to ROI. Let's run the code, and here we have the ROI, which is what we are interested into it. Now, as we've done in the previous video about back projection, so I suggest you, if you haven't watched it, to watch the video, because we're going to use back projection right now. So from the ROI, we are going to convert the image to HSV. So we will have HSV ROI is equals to cv2.cvt color ROI cv2.color BGR to HSV. So from this we can calculate the histogram. So HSV format has three values, three channels: hue, saturation, and value. We're going to use only the first channel to find our object. So we're going to take the histogram of only one channel. So ROI hist is equals to cv2.calc hist. We're going to calculate the histogram of the HSV ROI. We're going to take only the first channel, so index 0. We're not going to use any mask. The size is 180. We know that in the first channel, hue, the values go from 0 to 179. 0 is included, so all the size is 180 values. So the range is from 0 to 180. We say 180, but 180 is not included, so from 0 to 179. And I think that's all for the histogram. And let's print the histogram, ROI histogram. So this is what we get on the histogram, all the values. To calculate the back projection, we need to have an histogram which goes from 0 to 255. You can see that here goes from 0, the lowest, to I guess this is the highest, 1128. So we have, but we want the maximum to be 255. So we have this function called normalize to normalize the histogram, which is going to put this number in proportion from 0 to 255. So this 1128 will be 255, and for all the rest is going to calculate the proportion. So this one, it's, let's say, the half of this 1128. So if this is 255, this one is going to be the half, so 127.5 or close to that. So let's define ROI histogram is equals to cv2.normalize ROI hist from 0 to 255 and cv2.norm minimum and maximum. Let's print again ROI histogram, print ROI hist, and you can see this is the maximum 255, and then we have all the numbers in between from 0 to 255. Now, once we have the histogram, we can find the mask using the back projection. So what is going to give us the back projection? Back projection basically is going to tell us from this histogram, so from this histogram of the region of interest, tell me where this region of interest is in the image. So to do that, we need to convert the frame to HSV. So frame HSV is equals to cv2.cvt color frame cv2.color underscore VGR to HSV. And now we can create the mask. So mask is equals to cv2 dot calc back projection on HSV. We're going to use only the first channel, so channel 0. The histogram is the ROI histogram, so ROI hist, the range is from 0 to 180 and the scale is 1. So let's see the mask. cv2.imshow mask. So you can see the white part is where the histogram is similar in the image. In this case, the Listerine sticker has the same histogram of this part which is moving, which is the Listerine sticker. Okay, now we are in the most important part where we're going to apply the mean shift algorithm. So let's see what is the mean shift algorithm. Let me explain it in most simple words. So mean shift algorithm is going to find the area where there is the highest concentration of white points in this case. So in this case, using with the mask, the highest concentration of white points is this one, so where there is the sticker moving. Once found the concentration is going to give us the point where we can draw the rectangle. So let's do this. The mean shift gives us two values. First one is red, which basically tells us if he found something or not. Red true, we need red and actually I'm not even sure if it's red. Let's call it we don't need it anyway, so underscore. We need just the position, so track window is equals to cv2.mean shift. The image is the mask that we created using the back projection. Then we need to define a window where it's going to start. So the mean shift starts tracking from a certain window that we need to define at the beginning. And you will understand later on why and how it works. Let's first put the window that we actually calculated on the first frame. So x, y, width and height. So x, y, width and height. And then we need to define term criteria. So term criteria is actually the configuration of mean shift algorithm. We're not going to get into details about it, so let's just copy what I'm writing. Term criteria is equals to cv2.term criteria EPS term, then cv2.term criteria count 10 and 1. Now track window is giving us the points where we can draw our rectangle. So let's first see these points. Print track window. As you see, the position X and Y changes all the time, and here we have the width and the height, which is always the same. So let's get these details into a variable, and then from them let's draw a rectangle. X, Y, width and height is equals to track window, and now we can draw the rectangle. cv2.rectangle. We're going to draw the rectangle on the frame. The first point is X and Y. The second point is X plus width, actually X plus W, and Y plus H. The color, we're going to make it green, so 0 blue, 255 of green, and 0 of red. Thickness, let's make it 2. And now we have everything, I guess. So let's run the code. Let's see how it works. I will say it works really well. So basically with this, if I'm not wrong, let me check one moment to the docs. Okay, this is how many points is going to move on the mean shift, and this is the iteration of the algorithm. Okay, anyway, let's skip this. Now what you are probably most interested into it is to see how this is going to work in real time, getting the frame from the camera. So I'm going to just copy this video and put it on the website for you. And now I'm going to edit this one. So from the camera, so we need to get the camera cap is equal to cv2.video capture 0, and instead of video we have cap.read, and that should be actually everything. And let's run the code. Okay, this is real time. I'm talking right now and it's working real time. Not perfect 100%. You need to consider that I took the first frame before, so actually we are working with the frame that I took from the other video. I mean the ROI. cv2.im show ROI. So I'm going to use always this ROI, which I took like a couple of hours ago when there was even a different lighting, so it is a bit different right now. But anyway, you can see that it works. Now we're going to find two problems which the mean shift algorithm has. First one, the size of the rectangle is always the same, so it doesn't matter if the object is big or if it's really small, it still follows the movement, but the size of the rectangle is always the same. So mean shift algorithm doesn't detect the size. Another problem, mean shift starts tracking the object from a specific area. So now where you see the rectangle is going to find the biggest concentration of white points closer to this area. So if I come with the object from another unexpected side, the mean shift cannot detect the object. It's looking only for the concentration of white points in this area, but it does not get to this area. So to get again the object tracking, we need to move where the object is. Now it can detect bigger concentration and it will follow them. This problem, we're going to see how to solve these problems In another video especially, we're going to see the camshift algorithm as next to solve the problem about the size of the rectangle. And this is all for this video, and thanks for watching.